All right, welcome back. We're going to continue our discussion today with the product rule, but let's first just kind of review some old fun things to do here. So the first question they can look at, this is more of a warm-up and a review for us, is we want to find the horizontal tangents. That was me during the summertime. I lay down on the beach and I get a tan, and since I'm a gentleman, I am a horizontal tangent. Thank you, thank you. So anytime we deal with tangents, we're dealing with the slope of a function. And in a horizontal, we're saying that the slope is 0. So we want to find where the slope is 0 on this graph right here. And if I were to take the derivative, remember we're going to take the derivative because the derivative finds slope for us, we would get 3x squared minus 2x. And now we want to find the horizontal tangent. So now we want to find out where the slope of our function is 0. Now notice, I'm going to write this down because the AP is going to give me a point just for writing this part down right there. And we like that, plus 1 point. Set the derivative equal to 0. And don't bring the 2x over. That's a bad algebra right there. But what I can do is I can factor out the x. And that's going to give me 3x minus 2 is 0, or x is 0, and x is 2/3. Now if we look at the graph over here, this is what our graph looks like. This is an an odd positive function, so that tells us the end behavior. But what's nice about these two numbers right here is that these tell us where the slope is 0. Here the slope is 0, here the slope is 0. So I know the x-coordinates at x equals 0, and I know that this will be at x equals 2/3. Right there. These numbers are so special, we have a special name for them. They are called critical numbers. We use them all the time in math. They're very valuable for us. Anyway, so that's kind of that. But what's really nice about this is also what it can tell us. I almost forgot to tell you. Now I can look at this function. Before calculus, we could never do what we're about to do right now. I can actually determine where this function is increasing. And I know that this is going to be increasing from negative infinity to 0, or from 2/3 to infinity. And that is because the derivative, or the slope, is positive. So before calculus, we couldn't do this exactly, but now we're able to tell where the function is increasing, where is the function decreasing, all sorts of things with this. It's a really cool tool for us to have. All right, for our next example, this is a little bit trickier. Here we are given the third derivative of a function, and we want to find the fifth derivative. This is going to take a while. So I don't like this x to the square root of x, so I'm going to write this as x to the 1/2. So this is already my third derivative, so to get to the fifth derivative, we only need 2 derivatives. Let's review notation like we did before. When I take my fourth derivative, remember this is saying I'm taking the fourth derivative of y, and we're taking the derivative with respect to x for the 4th time. That's why we put the 4 and the x there at the bottom. When we take this derivative, this is going to become 1/2 x to the negative 1/2 plus, because the derivative of cosine is negative sign, so that becomes positive sine of x. Now normally I would put that x to the 1/2 on bottom, but I have to take one more derivative, and I'm going to go ahead and do that. The fifth derivative, I plead the fifth derivative. This, drop your power, we're now going to get negative 1/4 x, subtract 1, be careful, negative 3/2. I got into a fight once, I was negative 3/2. Plus the derivative of sine, which is cosine of x. Now I'm going to rewrite my answer. The fifth derivative of y with respect to x becomes negative 1/4x to the 3/2 plus cosine of x. And there's our answer right there. Very easy to do. So easy, Senior in May can do this. All right, next. Let's see here. Let's see what we can do next here. Same type of problem. Find the second derivative of this product right here. Now be careful. You might have heard the key word there, product. So what does that mean for us? We're going to use our product rule. That's right. This is our product rule. So let's review the product rule right here. This is going to be the first function times the derivative of our second plus the second function times the derivative of our first. There's our product rule right there. All right. That's our product rule. That's what we're going to be doing right now. So let's have some fun here. Ready? So when I take the first derivative, if I let this x squared be f and this cosine be g, when we take the first derivative, dy dx, we're going to write out the first, x squared, times the derivative of cosine, which is negative sine of x, plus the second, g of x, so cosine of x, times the derivative of the first, which is 2x. Stay nerdy, my friends. Dos Equis. Now, we're not done. We're not out of the woods yet. Because now we have two products that we have to do. So now we have to do the product rule not once, but twice to get our second derivative. This isn't going to be, terrible notation. This isn't going to be pretty, but we're going to get an answer. So let's look at the first one. If this is f, and this is g, right? There's f and there's g. If I take my derivative, I'm going to write out the first, x squared times the derivative of negative sine, which is negative cosine of x. Be careful, the derivative of sine is cosine, but we got that negative in front of it. Plus the second, negative sine of x, times the derivative of the first, which becomes 2x. Woo! Plus, now we have to do this one. If this is f and this is g, let's do it. The first, which is cosine of x, times the derivative of the second, plus the second, I should have wrote that in blue, in red, sorry. There we go. Plus the second, 2x, times the derivative of the first, negative sine of x. Now, an easy way to check it, you should have two products, two parts for the first product, and then two parts for the second, for a total of 4. So we got 1, 2, 3, 4. We're done. Do not simplify. Okay, I think this cleans up very nicely. You notice right here, right away, these are going to clean up pretty nicely. But don't worry about simplifying. Just get that answer. All right, pretty nasty. All right, the next one, let's see here. Analytic derivatives. Again, you're going to see these on the AP test. You're going to see these all over the place. So we're given that the value of the function at 4 is 2 of f. This is a value. This is a value of g at 4 is 3. But then they tell us the slopes. Remember, this f prime and g prime, these are my slopes. So you have two values and two slopes. You have the value and the slope for f at 4 and the value and the slope for 4 of g at 4. Excuse me. They want us to find h prime of 4 for the following. So we're told h of x is equal to the 3f of x minus g of x. So we just want to find the derivative. So I'm going to take my derivative. H prime of x is 3f prime of x minus g prime of x. All I have to do now is plug in a 4. 3f prime of 4 minus g prime of 4. And I'm just going to replace now h prime of 4, 3, f prime of 4 we know is 1, minus g prime of 4, which is 2, and we should get 1. So h prime of 4 is 1. Pretty easy to do. Nice job, everybody. For number 2, be careful. We're taking f times g. This is our product. We saw one like this yesterday, but with a graph. So be very careful. The mistake that people want to do, they want to do this. F prime of x times g prime of x. But that's not the product rule, and they know that because they'll never miss something like these up top. They'll never miss something like this one. So when we're doing the product rule here, you have to remember it's going to be the first function, f of x, times g prime of x, plus the second, g of x, times f prime of x. And then plug in the 4. H prime of 4, we get f of 4, g prime of 4, plus g of 4, times f prime of 4. There we go. and just plug in everything. F of 4 is going to be what? Negative 2. G prime of 4 is 2. G of 4 is 3. And F prime of 4 is 1. So we get negative 4 plus 3, so therefore I can say H prime of 4 is negative 1. Not hard to do. Not hard at all. All right, try it. Number 3 on your own real quick. This is a little bit trickier here. All right, so we're back. So when I want to take the derivative here, again, I'm going to have a product rule right here. Now, if you notice, to the g is attached this negative 2. So I'm going to keep this negative 2 at the g. It makes it a little bit easier for us. When we take the derivative of 3 is just 0. And now I'm going to do my derivative. The first function is this negative 2g of x. So it's going to be negative 2g of x times the derivative of f prime, plus the second, f of x times, and now I want the derivative of this negative 2. Well, that's just negative 2g prime of x right there. Keep the constant with the g right there. It makes it a little bit easier for us. And now when we plug in the 4, we'll get negative 2g of 4, f prime of 4, plus f of 4 times negative 2g prime of 4. And we just plug in everything. Negative 2, g of 4 is 3, f prime of 4 is 1, plus f of 4 is negative 2 times this negative 2 right here, and then g prime of 4 is 2. And when we clean this all up, you can leave it like this, that's cool, but we can clean it up really quickly here. We're going to get negative 6, 2 negative positive, plus 8, which is, I believe, 2. Maybe I messed up on the arithmetic there, which is why we don't normally simplify. I hope you enjoyed this video. Go to part 2. We'll finish up today's lesson. See you soon.